Well, this speech is not what I would call a traditional speech about someone. This is probably one of, if not my best friend. And what I want to talk about really was not only initially some of the accolades and some of the positives, of course, how it's done with his life. But I noticed something very interesting after a while with Dr. Katz's life, and it's there's some interesting trends that I think I've uncovered that might be interesting, especially interested in the professors here and also, you know, just to understand people. Can you hear me?
No, we can't hear.
Do you mind anything?
Okay. We got a mic.
They should have a mic in a room.
Well, they told me there's microphones up above. I guess they don't work.
No, we need a mic.
The mic is picking up for the Zoom, but not putting the sound back in here.
Oh, okay, so how do
Well,
I
your mic, no, you, that, use that.
This is better?
What? Oh.
Hello, okay, this is working now, okay, great. So what I was saying is this isn't your traditional accolades only speech, but I am gonna cover some of the positive aspects of Al Katz's parts in life and how he's contributed to so many areas, and it's all good. But because we're both baby boomers, and some of Al's background, and I realized the first time I understood Al Katz and what he was writing about was in the early 60s. So it turns out, and I'll get into this, but he was actually publishing a column in the early 60s in one of the few places where you can get an education on microwave technology and other types of radio technology. So, and I'm going to get into where you go for learning in the early days of the 50s and 60s. He was a little bit older than I was, but we shared the same place, location, and I was working in Trenton at a communications shop in the early 60s. So his name crossed my vision as he was editing a column for CQ magazine. Anyhow, so I'll get started. So the first part of this is what the speech I gave for the EME conference. We had a international Earth Moon Earth conference that was a spectacular success. And Paul Andrews really did an amazing job as a co-host for that. He was Al's co-host for the International EME 2024 microwave conference, and we had an amazing number of countries that showed up. And so what was really shocking was, you know, all the positive attributes, and the conference proceeded as normal in terms of technology. And you have a team of dedicated international people dedicated to improving communication over multiple handicaps. And there was some talk about communicating with deep space type of communication with very, very large dishes and into other planets and not just moon communication. So to me, it was a fantastic conference, lots of new technology, you know, developments that I would have loved. And so that was a big successful conference. So I opened the conference up with a lot of these hosts were international, so they came in here and they came to TCNJ. So this opening talks a little bit about Al's background at the college. So I wanted to open this up by telling his background with the college in New Jersey. Okay, so one thing I put up at the top of the screen is the nature of the name. The names have changed several times, which is interesting. So in 1908, this was called New Jersey State Normal School at Trenton. That's kind of a lengthy title, right? Long title. 1929's New Jersey State Teachers College. 1937, New Jersey State Teachers College at Trenton. They dropped the normal. 1958 was what I sometimes call it, which is Trenton State College. Kind of gives away my age, right? Trenton State. Well, and then of course, 1996, it was changed to a college in New Jersey. Now, I wanted to talk about specifically the engineering school and Al's impact. Al co-founded the engineering department here, and we get a little bit into that. And we just a snapshot of how many different engineering programs we have. And again, this was the conference for the International EME conference host. So he brought to TCNJ in '71. So again, he helped launch an engineering program designed to learn hands-on with rigorous technical training. So he was there from the beginning and helped build the department literally from nothing. And this is kind of an interesting fact because I've had many of his students actually visit and actually call me and said, you know, they wanted to sit down with Dr. Katz because he's mentored more than 2,000 students here and served as an advisor for senior projects. And then of course, Dr. Katz founded this conference, Trenton Computer Fair in '76, and we'll continue in 2025. We don't, beyond this still, we're working on it. And his call sign's K2, UYH. He also accomplished his big accomplishment in life, let me just tell you, is, and this is what, from a technology person to another technology guy, he's most proud of his Earth, Moon, Earth, worked all continents. So I was lucky to come into some archives and have got the archives from when Al was in high school. And one of the things that I decided, which would be very useful to share with everyone, is what was the spark that got Al interested in this technology? And I've actually taken information, and the first thing you want to know in a situation, especially in the '60s, you didn't have the internet. You didn't have the cell phone. You didn't have Zoom. Well, that was good, better times probably. But anyhow, so you didn't have all this global communication of sharing best practices or sharing ideas, sharing hobbies, sharing fun. So you didn't even have, at that time, you didn't even have the email list communities of interest. So you didn't, you know, think about when Al was in high school. He was in the same boat I was. Well, how do I get knowledge? You know, one thing Al is, he's a very curious person. And his metric is always, you know, what have I learned? And what, so he loved hard projects. You give him a hard project, he loved it. And he was a person that would call me from the airport and ask me if I would help him solve problems. And I would learn from many of his calls that I should always have a laptop open to the IEEE databases and the IEEE Explorer, which are all the worldwide, and the Elsevier databases, so I could get him some decent answers. And of course, my own files and own directories and databases. But anyhow, his proudest accomplishment, and we're going to get back to that, is EME worked all continents, and that was in 1976. And he worked on the historical Sarnoff artifacts collection, and right now we're still working on that. Now, a little bit more about TCNJ, and then we'll go right on. One thing important is Al worked for Lockheed Martin, and the technology that became LTI, which is his company that he started. It comes from the technology that's part of EME. So one is going to see a pattern here. I move forward, but he worked for Lockheed Martin and then he started his own company. But let me, I think these are fun facts of the college that I gave to the EME conference, International Conference. But I think many people know these facts. But one thing that wasn't so obvious is Al worked carefully with getting people published, getting some students published. And that continues today at TCNJ with Dr. Deese and so forth, is to have a collaborative effort with the students, which is a great thing that Al initiated. And but here's the kicker. Now, this is where it starts getting interesting. What's that? Can you hear okay?
Yeah.
Okay. So this is a very young Al Katz, and he's in his favorite place, which is where? That's his, some people call it a laboratory, some people call it a radio ham shack. But that's where he was happiest, is working in the he's a futurist. He's always had this big, great quest to lifelong learn in an area, like I said, in an era we didn't have the internet. We didn't have many things to share now, knowledge. But when you take a look at this picture and his favorite spot, at 12, he obtained his novice license, which is his federal license to transmit. And that was in 1956. He was 12 years old. This particular picture was taken when he was 16. Well, I couldn't resist the urge on this one. So I'm looking through photographs that I personally have taken of Al and a project we were working on together. What is this photograph of? I hold on to your seat. So this is 65 years later. Al is in the same spot. I'm not kidding. I saw this last night about 3 a.m. when I saw this last. I'm going to put this right next to when he was 16 years old. And so this is his favorite spot. And sometimes I'd come over, and what I would work on would be the spectrum. This is the panoramic view, or the spectrum with an SDR. That's where I was of value to Al. Was working on the looking at the IF of this down converter, and looking at the IF, he's looking at signals. There's either signals being bounced off the moon, so he can tell by the shape and size of the signal. There's all kinds of things he's learning from looking at the signal in detail. Very complex signal, and we're going to get into that. So I think at that time, always, all great people have one thing in common. You know what that is? You got a role model. Again, this is the 60s. I'm not going on the internet and meeting friends. I'm not in a chat group. I'm not in a group on advanced technology. I'm not in an IEEE conference. So what do? So he's sitting in high school and he's saying, "This is the guy I want to be." His name is Sam Harris. Sam Harris, his call sign is W1FZJ. This is Sam Harris's dish. So Al's a high school kid, and you see this particular column that Sam Harris wrote for The World Above 50, notice megahertz or mega cycles instead of megahertz. It gives you an idea. So again, without internet, Zoom, cell phones, how does a kid learn about microwave technology? Answer: hobby-specific magazines, mentors. I was in the same boat of Al, so I would be going every Tuesday night to the civil defense meeting where we were all communicating. Everybody's sitting there. I wasn't quite old enough to be called a communications engineer, but every person sitting in civil defense were all working on their communication skills, radio communication. So they all had expensive Collins equipment. They all had all their licenses. They had all their professional licenses. They had most of them had World War II experience in the communications branch. One guy, when I was a little kid going to this conference or these meetings, civil defense meetings, there was one guy from World War I. Now, I don't know, you're a young kid. I mean, how much can you learn from a World War I vet who's got communications background? I mean, this to me was a gold mine. This is the happiest time of my life, is sitting down next to people that lived through World War I. And new technology from a World War I perspective. He kept up over the years, so he was a pretty interesting guy to talk to. So Al's answer was the hobby-specific magazine. He wrote for CQ. He got every month the QST and 73 magazines, and like I said, radio clubs. So this guy wrote for QST. He wrote the column, "The World Above 50 Megahertz." Well, of course, Al looked at this and he said, "Yeah, I want a dish that size, you know." So now, he's being jealous of this guy's buys their dish. So now you know, Sally, why he wanted a bigger dish. He ended up with a 28-foot dish, so he did pretty well. You know, it's interesting how you measure things when your top priority is technology, you know. So anyhow, this was his mentor, Sam Harris. Now, Sam Harris was, he was a microwave consultant for a company named IMAC. IMAC controlled all the power amplifier tubes in that era, all through the 70s. So they owned the broadcast PA market, power amplifier market. So he was well-funded. He could buy dishes like this. He didn't have to make them. He made them for fun, but he was a pretty wealthy guy, so he could experiment all day and night. And this photo was taken of Sam Harris on his dish. You could think this was Al Katz, right? Because years later, this looks like the dishes that I'm going to show you. So this slide is from one of Al's presentations. So he admits he became interested in EME in high school. And right away, he says, everybody seemed to be using dish technology for the game, parabolic dish. And he calculated with his propagation or link propagation calculation, he needed a 60-inch dish for a 2 meter, 144, 146 megahertz communication bouncing off the moon and back. So a kid in high school, I mean, how are you going to afford a 60-foot dish? Let alone what kind of parents would put up with a 60-foot dish. You know, we talk about what is it? Community control today. My friends can't even get antennas, simple antennas up, and this guy wants a 60-foot dish. You know, so he gave up 60 foot and settled with 70 centimeter and a 30-foot dish. And he called it a stress dish is the design of how you actually form the parabola. They call it a stress test because you have to stress the structure, the wood, in this case, wood structure, so that you had the parabolic shape at the right concentration angles, you know. So here is the birth of Al's dish. That's I think Sally is still in the backyard, right?
This is the antenna raising.
Yes. Well, you should.
We have antenna raising.
Yeah, you know, Doug's in this picture too. Yeah. So these guys decided to see what they could scrounge for free. So they went looking for military and government surplus parts. Not only the dish, which they found a 28-foot dish, all they had to do was get it out of there, right? That's the rub. You got to get it out of there. He didn't have a truck then, did he, Sally?
No, they borrowed a truck
Oh,
and they took it, they brought it from where it was at Bell Labs. And they brought it
the
peacefully
labs, right?
in the truck And they knocked off, I think they only knocked down a few telephones at night, they thought nobody would see.
Yeah. Well, I think Doug told me that on the way home, they found the support structures on the side of the road. Ow, that's a little bit sketchy, isn't it?
Yes.
That's what Doug told me personally. He said, yeah, we found this stuff on the side of the road. Now, Doug, I think, is a skinny guy on the left, wasn't he?
Oh.
Anyhow, so this was his 28-foot surplus dish, which, good point, he got from Bell Labs. I don't know how he got a contact to hand him the dish, but they probably just wanted to get rid of it because they're being sold. This is probably the third or second time they were sold at that date. And then they had to get the thing up in the air and support it properly. And there's Al trying to align the collection where it has to be focused, the apex or the correction point of where to aim the feed. They call that a feed. And so he's aligning that, and he's looking at the bottom support structure there. And but he's very happy that he's got a 28-foot dish now. What more can you ask for in life, you know? So he quickly worked. He was the first one ever to work, meaning communicate to every continent on 432 megahertz. So he was the first of his kind to achieve that record. And he made the cover of QST. You know, I don't know, as a kid, if I made the cover of QST, I think I died and went to heaven, you know. But anyhow, he worked all continents.
How old was he then?
16. Well, that would be 76, so he's older than that. Yeah.
In his 30s?
No, he had to be around, we were married by then, I think, and so it was probably around 26.
26, yeah. Because he got the award sometime after he obviously put the dish up and did all his work in between. So 76 is when he got the award, 1976. And so just to think he's happy about that, there's a shot. So he's showing off his award, worked all continents. He's 30 something in that picture, yeah. We'll show her that. Okay, now what I thought I'd do is take some of his own material and try to get inside of his head to find out what's the appeal, you know? So the question is, what's the appeal? He spent 65 years on this hobby. I'll repeat that, 65 years working on this hobby. So this is in his own presentation. Why moon bounce? It's exciting. Most fun in ham radio is making rare, unusual, difficult contacts. EME allows you to worldwide distance on any band, 6 meters and up. Way to increase your grid square, STATA, DCX, count. So he's interested in a milestone of how many countries he can talk to from his signals bouncing off the moon. Now, why off the moon? I mean, it sounds like there's easier ways to do things, right? That's the point. He wasn't interested in the easy way to do things. Okay, so this is his own sketch. So from a communications engineering perspective, what you do is you calculate the link margin. So this is the margin on where you can communicate and make contact. So what's the sensitivity? What do I need as power? So there's a lot of variables that go into that. By sticking the moon in your path, up and down, you've added 261 decibels. 261 decibels to communication engineering is a nightmare. You wouldn't even think of that. I'd sit there and look, it's 261, I would just start laughing. So this is why I loved it. It was hard. It was difficult to do. Nobody was doing it. except Sam Harris, and even Sam Harris couldn't do some of the stuff at 2 meters that Al did. So, so he actually looked at what Sam Harris tried to do, since he had all the awards previously. And he realized the one thing he was doing wrong. He didn't calculate the effects of the ionization of a propagation, vertical versus horizontal propagation signal, that it flips if it goes through a strong ionized region. And that's what Sam Harris didn't figure, and Al found it out. So he cured that and worked all continents with it, 2 meters, the 144-46 megahertz. And it's, so this is his sketch and how he calculates 261 decibels at 432 now. Okay, so just to take the few of the bigger variables, there's a lot more variables. So you got to overcome 261 decibels of loss. So what's one to do? Well, you can increase the size of your antenna because you get higher antenna gain. You get a better path loss because you're making up for by the antenna size. You get gain from the passive gain, right? Because I don't need to put power into it. The other thing is increase your transmitter power if you want to get higher power. You overcome 261 decibels of loss. And receiver, you want your lowest noise figure. So you got to get down into the noise figure. So if you want to be a big gun, now he's saying you're rated on how much of these things can you do? These variables, how much can you change? Now, one of the things he didn't list right away is just using JT. So JT65 is a protocol that was invented by his other mentor. So he's had 2 mentors in life. One, like I say, is Sam Harris. The other one is Joe Taylor. So Joe Taylor single-handedly designed a series of lowest noise figure sensitivity, receiving sensitivity. So he took his knowledge, and I have some of his slides too. I'll show you where he's taken his knowledge and he's designed certain protocols that work at the noise floor, not below, but at the noise floor. And you're always limited by thermal noise. You're always limited by other types of noise. And so these are more variables, right? So I just named 2 or 3 more variables off the top of my head. So that's the challenge. So this is incredibly challenging. Now, to add to your scorecard is based on how many continents and countries that you can establish contact by bouncing at least one leg off the moon. So it's a handicap, right? 261 dB handicap. So Al has decided with the 261 dB handicap, how can he work certain countries, right? Because he wanted to get under continents. What's the next thing you want to achieve after worked all continents? You want to work all countries, right? So he's like, well, I don't have any hams in Bermuda today, you know? What am I going to do? So what would Al do? Sally, you know what Al would do, right? So here's Al sitting in Bermuda.
Oh, yes, I remember.
So he'd probably, you were there, I know you were there, this trip. So I used the slide where he would fly to the country he needed and he'd fly with a portable system, so-called portable. The size of these tables was portable to him. And I think, Sally, you helped him carry this stuff, right?
No.
No.
I think he did a long thing and he packed them all up.
Yeah, vertical box.
He made them all portable. That's all the antennas. He was very big on portable and mobile, and
Yeah.
so he would pack them all up and put them in the lawn. At one time, I gave him a golf bag. I thought he could put them in there and then ship them. Yeah. And I think sometimes he shipped.
Yeah, that's a good way to do it.
Our trip.
So for him to work the country that he couldn't work because there wasn't another ham that had a dish, He would fly to that country with his portable dish. And he'd take the assignment, you can do, it's legal. He can take the assignment of Bermuda, call sign of a Bermuda station. So now he had all his buddies that were trying to get points in Bermuda. He's now on site. So he's calling up his old buddies with his portable dish. Say, hey, we're online now. You need Bermuda? Here I am. You know, call me. Okay, so I guess
Well,
yeah,
I think the important thing, idea is if you look at that,
yeah,
it's all made with pieces of wood and chicken wire and old scraps of this, that, and the other thing,
yeah.
so that anybody could do it if they wanted. He was there to show them how.
Yeah. So in Al's head, he wanted a challenge. So look at Al as a lifelong learner. So what did he get from all this? There's no one that beats Al on microwave technology, that's for sure. So you got a government that's concerned about links, GPS or GNSS problems, it's very weak signals. How do we improve the coverage of GPS? Who are you gonna call? Well, this guy is a good candidate to call at LTI, his company. So he was getting a lot, I guess I can talk about that. He was getting government contracts because there's no one that knew microwave like Al Katz knew microwave, right? He's the guy that overcame a 261 decibel loss on the link margin. He's the guy, you know what else you're gonna call him on? Well, look at his list. Over 65 years, Al became the go-to guy for not only antennas, transmitters. So he was working for a contractor, government contractor, and says, I can improve the transmitter. He knows how to do that. Why? Because he spent years and years getting power output improved from his PA, his power amplifier. Remember, one of the big factors is dish size, the other factor is your transmitter efficiency. So if we can get power efficiency, it's the same as boosting power and meeting your ever difficult problem handicap of 261 dB loss. So he became an expert not only in antennas, but in how to distort the power amplifier to get away from both saturation and for nonlinearities. So that's this big news. Every government agency that needs a transmitter is going to want to use that. That's when he left his company or a company to start his own company. Was it Martin Marietta or Lockheed, right? So he left Lockheed and he got his patent from Lockheed and says, I want to start my own company. But their deal was, you got to still keep the suppliers happy with your pre-distortion solution, which is the linearization by adding some programmed distortion or nonlinearities to correct the distortion that's in your power amplifier. So he became the world's expert in this. He's it. He's your go-to guy. If you want to improve power efficiency, you call LTI. And one of the reasons why Macom bought the company is because he had the patents and he had the knowledge to linearize an amplifier. That's why he called his company a linearizer. That was his big thing. As far as receiver technology, he was also, and when we talk about GPS, the problem is low power, high losses, same thing you got with Moonbound. So how do you improve the receiver? Well, you change the bandwidth. You get what's called you got a thermal noise floor, and you solve that problem by one variable you can do is to solve bring down the noise floor, the noise figure floor, and the way to do that is by changing your bandwidth. Now, take your bandwidth and keep reducing it. How far can you go? Well, then you get problems of stability, you know, you got a transmitter oscillator, you got drift, and you have a very narrow bandwidth, you've got some issues, so you got some engineering issues with that. He solved all those, okay, he's worth it. Now, his other mentor solved the noise floor because he's right at the noise, the Johnson noise limit, using the calculation against the noise floor by reducing the bandwidth. Joe Taylor has figured a whole set of protocols to get around that problem of reducing the bandwidth and still get close to the noise floor, because you can't get below that at this point. Now, you could put super cool, you know, there are receivers and receiving antenna, receiving LNAs that you can drop the temperature so you can reduce the thermal noise floor, right? By taking the thermal factor out, bringing it close to liquid helium or liquid nitrogen, not nitrogen, helium. Helium is the coldest. So if you get 3 degrees above liquid, you've changed the whole Boltzmann constant, and you reduce that. Anyhow, his other buddy, Joe Taylor, figured out what the protocol is to take advantage of that. And what the protocol is how to maximize your benefit. Now, the other problems you're faced with when you're solving EME is you're facing propagation problems. You're creating inter-symbol interference because of the propagation and the moon's deflection and the moon's reflectivity. You've got errors in that. And you have a problem called Doppler. So Doppler is a big deal. So what happens in Doppler, you're changing the frequency because you're moving the signal all the way up to the moon and back. You got a Doppler problem, which is the frequency is effectively shifting. That's the definition of Doppler because of velocity. So now Al's figured out a way to get around the Doppler effect. Now, how important is that for the government, the military? He knows how to correct for the Doppler. So I guess my point here is all these contributions he did from one hobby. Was he obsessive? Yeah, I think he's obsessive. But look how positive, you know, Al's life turned out. I mean, big guy in demand. I mean, for any kind of communication, this is your go-to guy. Now think of how many problems they've had in communication where you need somebody who knows all this. Well, again, Al's training because of his hobby. You know, he's having fun. He's not doing hard work. He never saw that as work. This is always fun. So if you say, Al, you can do anything you want today. What do you want to do? You know what you do? I'll show you what you do. You know where I'm going to go to, right? So, or conversely, it's 3 in the morning and Al's busy because the moon's alignment is in a good position for working in Japan. A very true story. Sure. So this is Al's fun hobby that he's turned into a career that's set standards for power gain, power amplifier gain by using pre-distortion. He's turned into the whole idea of propagation, where they say you can't work this less than a 60-foot dish. You can work it now with like a 3-foot dish now. There's the EME conference that I attended, this one last year. Yeah, I got a 3-foot dish, no problem. He's actually sending video off the moon. But he's learned all this from what Al did, you know, from his initial work and his. So here's a guy who's incredibly passionate about his hobby, right? 65 years in one hobby. And that's what I tell students today. I said, you really want to be good at something, right? Don't just sit here and waste your time. Be passionate about something to do, because you can do it the rest of your life and make money and have fun. Anyhow, that's pretty much my presentation. And I'm around for questions, or, you know, I'm an amateur. I'm not an amateur. I'm not even, it's just watching him, and it's just, his pursuit of knowledge is amazing. And now you have tools he didn't even have in the early days, but now he's got the great tools and databases and knowledge that's being made every day in this technology. But be good at something, because he was known as somebody, he's known as the expert. Well, you know, if somebody's identified as the expert, who's the guy that's gonna get the business? Make the money, right? You gotta call the expert, especially if you've got a consulting business. As a consulting business, I'm worthless unless they say, hey, Joe's good at this narrowband technology, you know? And that's how I get customers. But and that's the way he eventually sold his company to Maycom and did very well, you know? And so I tell all my students, be good at something. All right, this is it. That's all I got.
How many